Hello and greetings from Newtonian thinkers. Today we are giving a general overview of studying and learning physics. If you intend on studying physics, you will most likely devote a considerable amount of time to this endeavor. It would be best if you have a good perspective, which will improve your chances of success. Here are 10 points that are worthy of discussion. Number 1. Physics is very deep. It has taken 300 years to package physics into its present form. Physics is the most mature science and requires the most math. Most parts of physics cannot be learned in a single sitting, a single reading, a single homework session, or even in a single course. Number 2. Learning physics is by nature a cyclical process. You will learn more watching if you read first. You will have more success solving if you have read and watched. Solving is the most critical phase of learning physics. Watching an intelligent person in a video can give us an inflated sense of our understanding. Actually taking out a pencil and writing down some equations will help keep us honest, as we will truly know how much we know or don't know. Don't think that your teachers or professors are out of date or out of touch by insisting that you work out things with nothing but a pencil and paper. Using your own brain and nothing else is still a vital exercise in education, and I would bet that it always will be. Number 3. There are micro and macro cycles in learning physics, or just about any other deep subject. A microcycle is learning a specific topic such as one-dimensional motion. Read, watch, solve, and repeat as necessary. A macrocycle is learning a major part of physics, such as mechanics. Learn mechanics, learn some more math, maybe even some chemistry, then learn some more mechanics. Understanding the relationship of a subject to other surrounding subjects is an important part of understanding the subject itself, and this requires a macrocycle of learning. By design, most foreign countries have a macrocyclical curriculum. High school physics in most countries may involve anywhere from 2 to 5 classes in physics, and thus includes 2 to 5 macrocycles. Most states in this country have one high school physics course, most often taught by a teacher with an incomplete understanding of the subject. I would call this a half of a cycle at best. Building macrocycles into a curriculum makes learning easier and less painful, and allows for a much deeper understanding. Why? Many topics that are covered early in physics are further elucidated during the later part of the course. Such later topics can, in turn, further elucidate topics at the beginning of the next course. Foreign countries have figured this out, while policymakers in the United States have not. Physics is not painful in most foreign countries, yet very deep. Physics can be very painful in the United States, but is not deep. I would guess that on a per capita basis, more United States students would say they dislike physics than in any other country. I would also guess that no public official, either at the state or local level, has ever been elected on a platform of requiring more physics. School boards are elected in this country. I would finally conjecture that with massive amounts of funding leaving education, nothing is going to be done about the dismal state of physics education in the US for a very long time. Number 4. The vast majority of physics concepts are learned by making mistakes during the solving phase, so we should encourage students to make mistakes. Most difficult problems begin with a feeble attempt, resulting in an incorrect answer. The real learning takes place when we sift through our work, looking for the mistake or mistakes. Our first attempts at difficult problems in subjects we are unfamiliar with usually involve conceptual mistakes or outright gaps in our understanding. It follows, then, that at first we have many major misconceptions that need to be ironed out. This is where the real learning takes place. Such learning rarely, if ever, takes place by watching a video or reading a text. One does not become a football player by watching a game on Sunday. One becomes a football player by getting out on the field and playing. And also it is with physics. Number 5. Math is the language of physics. Sir Isaac Newton developed calculus at roughly the same time as physics, simply because calculus was required to formulate it. Physics is more than math, but your math level limits your understanding of physics. Math is a necessary part of the macro learning cycle. Our first encounter with F equals ma usually involves substituting some numbers and calculating. Soon after, we learn that F equals ma is a vector equation, so now we have to learn vector algebra. Later still, we learn that the force F can vary with position, as is the case with Hooke's law, and we have negative kx equals ma. Further still, a is the second time derivative of the position x, so negative kx equals mx double prime, which is a differential equation and can only be learned after taking a couple years of calculus. The only way to completely unfold Newton's second law in all of its significance is to become a pretty good mathematician. The trend in the US to strip high school physics of most of its math content is a really bad idea. Conceptual physics wouldn't be such a bad idea if it was followed up with more math and then more physics, but this is never done. Conceptual physics is always offered as a replacement for a more quantitative physics course, most likely because we have so many biology and earth science teachers teaching physics, and we also have so many poorly prepared math teachers, but that is another matter. Number 6. If you feel lost when first learning a specific topic, welcome to the club. Believe it or not, even college professors fumbled through most of this material at one time. The ease with which a professor moves through the material should not be taken as a measure of superior ability, but rather a measure of how many thousands of hours the professor has spent rehearsing and contemplating the subject. When first learning a new topic, you will often be lost at first, sometimes hopelessly so. Physics students generally learn that even the most daunting topics can be mastered given sufficient time. Little by little, what seems like an impenetrable edifice can be overcome. The confidence that follows is an invaluable result of a good physics education. Number 7. Learning physics takes a lot of patience. Some topics will come easy, while others will not. Everyone brings a different set of tools to the table, and everyone has their own particular list of weaknesses. There will be times when hours on end will be spent uncovering what, in retrospect, will seem like a trivial point. Number 8. A vast majority of students in the United States will say, "I hate physics." I don't believe any of them. What they really mean is that they hated the experience of learning physics. I doubt that there are any students who hate physics. I have never met one person who has a strong distaste for understanding how things work. Some students may have no particular interest in understanding how mechanical systems work, but I have never met one person who covers their ears when it is explained to them that gravity keeps the Earth in orbit around the Sun. Almost everyone in the United States develops a quite sophisticated language skills. Yet I have never met one person who hates talking. The reason is, language skills are acquired at a very modest pace. On the other hand, picture what our disposition towards English would be if our native language was French, we were taught English by a Japanese teacher who spoke in broken English, and we had 3 weeks to read War and Peace. Most of us would end up with a serious stuttering problem. Fewer students would hate physics if we followed the cue of the rest of the world. Having multiple cycles of physics instruction in high school would allow for many more successful physics students, and would definitely decrease the level of hostility towards the subject. US students may be, as a group, a little lazier than students in some other countries, simply because we do still have vast amounts of wealth, but I don't think that this accounts for even a small fraction of the disparity in the performance of high school physics students. I put the blame squarely on our system. Number 9. A large portion of physics can be mastered to the point of it being second nature. Key formulas can be memorized without harming a child's brain, and key procedures can be mastered. The only harm that can come as a result of memorization is in assuming that memorization of facts and simple procedures is all there is to mastering physics, or also that undue stress is put upon memorization to the point of requiring an encyclopedic set of facts. Memorization followed by a deep understanding is and always will be a valid method of teaching. Number 10. Any part of physics, particularly mechanics, is not fully mastered until key derivations and proofs are fully understood. In the United States high schools, this is rarely ever done, since we have only one macrocycle, usually taught by a teacher who probably doesn't understand any of the derivations or proofs. So why are they necessary? First of all, when a student solves a problem from the text, they understand how to solve one problem, and do not necessarily have a complete picture of the principle involved. Understanding a derivation will help a student understand the scope and limits of the various formulas and principles. Consider, for example, s equals s of I plus v of I t plus 1/2 at squared. A student initially learns to use this formula when a problem includes the words constant acceleration. Such comprehension is still incomplete unless the student thoroughly understands what constant acceleration means and under what conditions we use it. The student will not fully understand the formula unless they can confidently use it in a situation where there is constant acceleration without it being explicitly stated, and they can also use it when a force or system of forces gives rise to constant acceleration. Since the derivation of the formula makes use of v of f equals v of I plus at, The derivation will thus be connected with other fundamental problems more directly tied to the concept of constant acceleration. Second of all, deductive reasoning is used to derive pretty much all of mechanics. Coefficients of friction and other physical constants are measured empirically, but the rest is all held together by derivations. Such derivations are part of physics, and more generally, part of any scientific research program. Derivations are, then, part of scientific literacy. We can merely tell the student that derivations are part of science, but the majority of students will have a more complete understanding of this if they experience science by learning the derivations. Derivations and proofs are easily understood when a student is familiar with key definitions and concepts. In other words, the student should be thoroughly familiar with what is being derived before he or she is expected to understand the derivation. Otherwise, the student is merely memorizing a sequence of symbols without any particular meaning, say, like memorizing the first 1,000 digits of pi. Since United States physics students only make one brief pass through physics, understanding pertinent derivations is a near impossibility. All we can ask is that the student becomes remotely familiar with various concepts. A second or third course could take the student deeper, with a full understanding of applicable derivations. College level physics is taught at a very high level, often with a multitude of derivations and proofs. The expectation is that the student has had a very thorough preparation in high school, and that college level physics is the next step of abstraction and rigor. Such is rarely the case, unless the student has had high school and then AP physics, preferably with a highly skilled teacher. This is a rarity in the US and only exists in rich suburban school districts. For a complete transcript, please visit NewtonianThinkers.com. Thank you.